this inside function staying the same. 8 is next. F of x equals 1 over cosine of 2x. So this is like cosine is to the negative 1 power. So cosine to the negative 1, 2x. So it's like a composite function. We've got like the negative 1 on the very outside, then cosine, then 2x. Okay. Oh, I used to do this. This would be fun. So it's like my negative 1 power is the blue. That's the outermost function. My cosine is the middle function, yellow. And then my innermost function is the 2x. Okay, so it's like I have 3 layers to this composite function. So when I'm taking my derivative, the first thing I want to do is take the derivative of the outside piece, the blue piece. So I'm putting the negative 1 out in the front, and then I'm putting my other stuff, the pink and the yellow, inside of that function the same. So cosine of 2x, but instead of to the negative first power, it needs to be to the negative second power because I'm using the power rule to differentiate the blue part. So the blue part differentiated was this part right here. Then I need to multiply, oh, I ran out of space. Whoa, that's too far. Then I need to multiply that by the derivative of the yellow piece. Now the derivative of cosine is negative sine, and I keep my inside piece the same. So this was my derivative of my yellow piece, the negative sine of whatever. Okay, now I have to take the derivative of my pink piece, multiply the one highlighter that I dropped was the pink one. What on earth is that thing, this thing in the corner? It looks terrifying. What is that? It's not my plant. Oh, it's this. It's like, what is that? Okay, it's my thing. All right. It looks like a head staring down at me. Anyways, 2x. The derivative of 2x is 2. Okay. So I've taken the derivative of my blue, my pink, and my yellow pieces, and I put it all together. Now, if I actually simplify this, I have 2 negatives that should make a positive. My coefficient, when I multiply 2 and 1, should be 2. So I should have positive 2. This is to the negative power, so I can put it on the denominator. So cosine squared 2x. And then I have sine of 2x on top. I should check the answers in the back of the book. They may have simplified this as 2 tangent 2x secant 2x or something like that. Hopefully that's not the case and we can just leave it like this. I'll double check it before I post solutions and I can show you how to fix it, I guess. 9, we're almost done. Maybe this won't be as long as I thought. We have y equals 4 over, now I feel like this thing is messed up. Oh well. 4 over sine squared pi x. So here my y prime, I can rewrite this. I'm going to go ahead and do that. Sine to the negative 2 of pi x. So again, here we have like 3 layers of our function. We have the negative 1 power is the outside piece, then sine is my middle piece, and then pi x is my very inside piece. So I have to go in that order. Oh, this is negative 2. I have to go in that order when I take the derivative. So first, the outermost is the negative 2. So I need to put negative 2 as my coefficient. And then, oh man, and that's multiplied by this 4 that's a coefficient right there. Okay, and then I need to keep the inside stuff the same, sine of pi x, and then raise it to a new power, which is the old power minus 1, so negative 3. Then I have to multiply by the derivative of this sine. The derivative of sine is cosine. And then I have to multiply by the derivative of the innermost piece. The derivative of pi x is pi. So then my final answer here should be negative 8 pi cosine of pi x all over sine cubed of pi x. This was the one that like most people got wrong. A lot of you got it wrong. So if you got it wrong, don't feel bad. Most people got it wrong. You could have also done the quotient rule with this and had the top function be 4 and the bottom function be sine squared pi x. Either one is fine. It's really honestly just keeping track of your like composite pieces. And then lastly is 10. There were definitely a lot of questions about when you have a trig function inside of another trig function. So here's an example of that. We have f of x equals sine of sine x. So this is the same sort of idea. We have the outermost function, which in this case is sine. The middle function, which in this case is also sine. And then the innermost function is the x, which is pink. Okay, so first we take the derivative of the outside function. The derivative of sine is cosine. I keep the inside the same. Multiply by the derivative of the middle piece, which is cosine. And then the derivative of x is just 1. So if I label my derivatives here, my blue derivative was this guy. My yellow derivative was this guy. And then my pink derivative was this guy. Hopefully the colors make it a little bit more clear. And then when I simplify this, it's pretty much simplified. You would just have cosine of sine x times cosine x. Oh, my pen is dying. Good, I picked another pen that was dying. Oh well. And then 1 is just the coefficient out front. Okay, hopefully this helped make it a little bit make more sense. Hope you guys are also wearing wacky outfits unintentionally and that you're doing well emotionally. I know this is probably crazy. I'm going a little bit crazy. I miss getting coffee with people and running with friends instead of running by myself all the time. It's lame. Anyways, I love you guys, and I'll see you later.